Okay, so we will continue our go through. So this part is for question 3 onwards. So question 3a is actually a standard question about wave, asking you what is meant by longitudinal wave. So when you are describing longitudinal wave or transverse wave, the most important thing is that you mention two things. That is the direction of vibration, and then you also need to mention the direction of wave travel. So since you are talking about longitudinal wave, basically you just need to fill this in. L wave, you don't use L wave in your test. I'm just using the short form in our go through video. So your longitudinal wave basically is a wave whereby whereby is a better word, so let me erase this, whereby the direction of vibration is parallel to the direction of wave travel. Full stop. That's it. Done. If you want to talk about T wave, what you need to do is change the heading here. T wave, transverse wave, is wave whereby the direction of vibration is perpendicular to the direction of wave travel. So you just need to remember the most important thing to mention about these two directions and then change the word here. Can? Okay, next thing for your part B, this one you can refer to your textbook for answer. But in actual, when it is in exam, you are expected to be able to recall this entire description on how sound is being produced and how the sound travel to your ear. So this is some standard O-level question that you need to learn how to answer. So what is the standard question? Basically, they will ask you to describe how sound travel to your ear. Okay, they will give you a context. For example, the drum is being struck, the tuning fork is being struck. So you need to mention what is the source of the sound. Okay, so for example, if the context is a drum is struck, then you need to say sound wave propagate when the drum vibrate. Okay, or when your tuning fork vibrate. Okay, so on and so forth. You go and fill up the subject matter. Okay, and this subject matter you get from the context. Okay, so you need to tell the examiner that you know, okay, this thing vibrate and it will push and pull the adjacent, okay, adjacent, how to spell adjacent? Adjacent layer of molecule. So this is one of the keyword you need to learn, adjacent. If I spell it wrong, please use the right spelling, okay? Then this will create, most of you got it right, this one is your compression, which you all spell correctly. Refraction, some of you spell wrong. There's only 2 R in refraction. Okay, then there's this ridiculous guy who spelled refraction. That one is for light. Okay, then you need to also learn how to describe allowing the sound to propagate. Okay, this is a keyword. And don't forget, there's this keyword also. It's a series of compression, refraction. So all these keyword you need to learn. Okay, we are looking out for them. Two difference of electromagnetic wave compared to sound wave. So electromagnetic wave, well, your EM wave does not need a medium. Okay, it does not require a medium to travel. Don't stop here. Remember, it is a comparison, but your sound wave does. Okay, another key thing, the difference is your EM wave is actually a transverse wave, but your sound is a longitudinal wave. Some of you want to talk about your EM wave travel at a speed of 3 times 10 to the power of 8 meter per second. But remember, there is this keyword, in vacuum. Okay, you need to tell me it's in a vacuum. In other medium, it is not 3 times 10 to the power of 8. Okay, and sound travel I think 300 meters per second in air. Okay, the next question, it is quite straightforward. You are supposed to do twice the pitch but half the loudness. So you need to know that your loudness corresponds to the amplitude. Okay, and your pitch corresponds to the frequency. So this one is a displacement time. So meaning that if you want to twice the pitch, you need to twice the frequency. Meaning that the time taken to make one wave, if you twice the frequency, it means that now this time here you have to make 2 complete wave. Okay, and because they say half the loudness, it also means that your amplitude down here need to be half. So since the question gives you a value here, 0.20, you are expected to give me the value of your new amplitude as well. So a lot of you forget to do that. Then once you have that, draw your curve carefully. So use dotted line, limit your graph to this bandwidth. Okay, and you are supposed to draw one complete wave within here to here. So you need to be very careful. So when you draw, even for me, I also need to plan and draw. Plan and draw. Okay, then plan and draw. So I need to do this. You see, even I have to do it, so I don't think you can freehand. You need to plan. So do this carefully. Judah, use pencil. Okay? So this is for your question 3. Yeah? Okay, so let's continue. I have to plug up my mic, so that's why my voice sounds like it is echoing because I'm in my bedroom. I have to use the mic port to charge my iPad. As you can see, my battery is very low, 7%. Okay, this last one is about whether you can trace the sound wave. So what happened? You have a girl and then you have a boy. So the girl will scream. When it screams, some of the sound will travel to the right, the other sound will travel to her left and then rebound. Okay, so there will be an echo. So this part here is the echo and this one is the actual sound. The bottom one is the actual sound. So why does the boy hear 2 bang? You need to tell me each bang what is it. So don't just give me your answer, oh, because the second bang is an echo. But you didn't mention what is the first bang. So you need to tell me that the first bang comes directly from the pistol. And your second bang, okay, is an echo when the sound reflect at the wall. So you need to tell me first bang, second bang. Okay, most of your answer just give me, oh, second bang is an echo, full stop, cannot. Then most of you forget to draw this. Okay, I want to see it. Can? Then after that, you are supposed to calculate the speed of the sound. So what do? Very simple. You know that it is 1 second apart. So most of you go and use some formula that I don't understand. When you are doing this, right, you need to learn how to write words and convert it to mathematics. So let's say now you know that the 2 sound is 1 second apart. I want you to translate it into a math expression. So meaning the time taken for second bang minus the time taken for first bang is equals to 1 second. So this is what I mean by you translate the words into a math expression. Why is it that you need to master these skills? Because there are other calculations that requires you to do that. Okay, So what you learn about the formula is how do you expand this thing. What do I mean by expand? Listen carefully. You learn that speed is equals to distance divided by time. Okay, remember you can only use this when the speed is constant, like when the speed of sound is constant. If there is acceleration, you need to use speed time graph. Okay, so speed equals to distance times time. So if you now want to express time, you will need to write distance divided by speed. This is your basic algebra. So when you do that, this one will become the second bank travel how many distance? Your second bank travel 150, 150, 350, correct? So therefore down here you will write it as the distance traveled by second bank 150 plus 150 plus 350 over the speed which you do not know minus what is the distance traveled by the first bank. Distance traveled by the first bank is just this much. So therefore this one will be 350. This is the speed. Some of you may be in your mind asking, teacher, I don't get it. How come this thing suddenly become a fraction? Because remember, your time taken for your first bank is given by distance travel over speed. So time taken for first bank, then you look at distance for the first bank, which is 350. Can? So once you do this, you will be able to form this equation whereby 150 plus 150, 300, 650 over speed plus 350 over speed equals to 1, the same denominator, so 1 equals to 6, 7, 8, 9, 1000 over S. So what is your S? Your S is, or maybe I put here, your S is 1000. So what is the speed? 1000 meter per second. And that's how you do it. Okay, let's carry on with your question 6. Question 6 is about this cylinder having a volume of oil, and you are told the total mass of the cylinder and oil is 1200 and the mass of cylinder is 800. So from this information, you know volume of oil is 460 cm cube. If you want to find the mass of oil, you need to subtract 1002 minus 800 and you will get 400 gram. So with these two information, you can actually find your density by doing mass over the volume. You will actually get, let me press my calculator, 400 divided by 460, you will get about 0.870 gram per cm cube. You notice that I put down the unit because whenever you are dealing with physics, unit will determine whether your answer is correct or not. Okay, so after I find the density, I don't know for what, I go and look at it. Okay, I want to calculate pressure. Well, pressure got a lot of formula. One approach is pressure equals to force over the area. So if I look at the pressure acting on this surface, what does the F stands for? Well, the F in this case stands for the weight of the oil. Correct? And what is the area? Area will refer to this cross-sectional area, right? So you may ask, teacher, but the information here didn't give. Well, they give, you just need to process it. What is the weight of the oil? Weight of the oil isn't it equals to mass times gravity, which is 0.4 kg times 10. Okay, you need to remember to convert this to kg. I got 400 gram, convert it to kg. So once I do that, I will know that it is 4 Newton Then teacher, what is the area? Area didn't give what? But they give you the volume, correct or not? And they give you the height. So how to find the cross-sectional area? Well, volume is equals to area times height, right? So volume is 460. A I do not know. This is my height. So I can actually find my area equals to 460 divided by 20. I will get 23, and this is cm cube. Okay, if I want to sub into this formula, I must ensure that this guy is meter cube and this guy is not meter cube, meter square. Sorry, this one also wrong. Okay, it has to be meter square. This one is meter square and this must be in Newton. So I need to do something with this. So after I convert this thing, it will be 0.23 times 0.01. This thing comes to 2.3 times 10 to the power of minus 3 meter square. So what I do, I just sub into this value, 4 divided by 2.3 times 10 to the power of minus 3. So what answer will I get? I will get I will get 1740 PA 3SF. And some of you may ask me, teacher, then in that case, why do you show me all this funny thing? Well, because some of you, your class, want to use the other formula, P equals to rho GH. You can do it, but remember your rho is kilogram per meter cube and your height is in meter as well. So if you sub it in, okay, you need to change your 0.870 into kilogram. So how do you do it? Please go and revise. I know how to do it, so I will just do this super method. Okay, gram per cm cube. So my thingy is 0.870. 0.870. So it will come to 870 kg per meter cube. So now I go back here. I know this is 8. Okay, sorry. So this is now 870 times 10. My height, this height is in cm, so change it to meter. Okay, so if I press the calculator, I will get 1740 PA. Ta-ta! Same value. Okay? Okay, last question, electricity. Okay, please go and revise your formula for your test. V equals to E over Q, I equals to Q over T, and finally R equals to V over I. You will definitely need these three formula for the test. But for this exercise, you need to recall certain thing. Number one, in your series, your current is the same, and your V is shared. But in parallel, your I is shared, but your V is the same. So let's look at this. I want to find resistance of lamp 1, right? So my focus is this guy here. I was told that it is 24, so I already got this. And I was also told that the voltmeter is 8V, so I will write this down. This is 8V. And then your ammeter reads 0.5 ampere. And I know that, well, this current will go into here, then it will split. Once it split, I do not know the value, but when it converges back into the main line, this guy here is also going to have 0.5 ampere. Okay, and I also know that this entire thing, if I imagine this entire thing, this yellow box, as one resistor, then I can say that this giant resistor is in series with my lamp. So in series, we say that the voltage is being shared, right? So this 24 volt is now being shared by this giant yellow box and this lamp. So therefore, the V across L1 is actually equals to 24 minus 8, which is about 6V. And I also know I that runs through L1, which is 0.5 ampere. So if I want to find the resistance, what kind of formula do I use? Chang chang. V equals to IR. So if I use that, I need to sub in the right value. This is 6. A lot of you give me 24. Some of you give me 8. But it is not. It is 6. It is the voltage across the L1. For those who are with me in set 4, remember, you should put this line. I want to apply V equals to IR at just L1. So when I want to do that, I know that V I want to find is only for L1. So V across L1 is 6. I for L1 is 0.5. And of course R for L1. So once I do that, I will know that R for L1 is 6 divided by 0.5, which is 12. So remember 3SF. Okay, but in this case, you give 2SF also can. Okay, so I will just leave it as 2SF. As long as you are 2 to 3SF, you are fine. But 1SF confirm wrong. Okay, so next thing, I'm supposed to find the current through R1. Okay, the other information given here is that I know R1 and R2 are identical in nature. Meaning that when the current split, sorry, I split the wrong way. There shouldn't be any current split into the voltmeter. It should split this way. Okay, sorry, let me draw the box again. Yeah, like that. Okay, so because it's split this way, that means the R1 and R2 is the same resistance, right? So the current that we split is just half-half. So down here I will get 0.25. Down here I get 0.25. So from here I will know, because your R1 equals to R2. So therefore your 0.5 will split, okay, 50-50 ratio. So therefore my current through R1 is 0.25 ampere. Okay, then I want to find my R2. So now you see that I already know my current through R2. I also know the voltage of R2 because in parallel the voltage is the same. So because R1 is parallel to R2, so therefore your voltage across R2 is 8 volt. So same thing, I will apply V equals to IR at R2. So V at R2 is 8, I at R2 is 0.25. I can find my R. So once I do that, I will get 8 divided by 0.25. I will get 32. So here I will write 32 ohm. Can? So what is the total resistance of the circuit? So down here I know this guy is 32 ohm. 32 ohm. And I also know R1 is how many? Where? Oh, sorry, I made another mistake. This one shouldn't be V. This one should be ohm. So therefore this is 12 ohm. So first you deal with this pair of resistor first, okay, because they are in parallel. Not because they are in parallel, because they are together first. So I will have to deal with this. Then once I deal with this entire thing is in series with my L1. So if I want to do it, it will be 1 over 32 plus 1 over 32. Remember, you have this plus 12 because they are in series. So I think I will get 28. Okay, for those who don't understand what is this, remember if it is parallel, it's like that. So if you do your math, your R effective is 1 over this entire thing. So this entire thing is the same as this format. Can? Okay. 2 additional resistor is acted to R1 and R2. What will happen to the brightness? So remember, brightness refers to the power P. How much electrical energy is converted to light energy. The higher the power, the brighter it is. Okay, so if you look here, there are many ways to explain it. You need to know something. If now you have R1 and R2 in parallel, okay, if you decided that you want to add more, let's say you add one more and you will add one more, and they are all identical, I'll let you compare. 1 over R effective. Now you have 1 over 32 plus 1 over 32 plus 1 over 32 plus 1 over 32. In the end, you will get 1 over R effective equals to 4 over 32. So therefore, your R effective will become 32 over 4. Can you see that the more the resistor you add in parallel, the lower the effective resistance. So this entire working shows you that when you add resistor in parallel, okay, the more you add, the lower the R effective. So when this question says that you want to add another 2 more identical resistor, basically this yellow box here, the R effective would drop. And if your R effective here drop, then the share of voltage it will get from your battery will be lower. And if they get a lower share, it means that this light bulb will get a bigger share of the V. So you also know that your P is equals to V squared over R. If now the V here increase, so this guy here increase, that means your P will increase. Okay, so that's how it works. So how do you answer and phrase it? Well, you need to say whatever I just said. Okay, when your additional resistor is added in parallel, the effective resistance of R1, R2, R3 and R4. What is R2, R3, R4? R3, R4 is the additional thing that you add lah, will be lower. Okay, so when this whole thing have a lower resistance, that means you imagine this thing is now swapped to here, then the share of voltage it get from the battery will be lower. And if this share is lower, that means this share will be higher. So because of that, the voltage across R1 plus R2 plus R3 plus R4 will be lower. So the V across the lamp L1 will increase. So by P equals to V square over R, when this V square not V2 let me draw properly, later you all don't understand. V square over R. Okay, so when your V across L1 increase, then obviously the P of L1 will increase, so it will become brighter. So I hope after this lesson you will also become brighter. Okay, that's it.